Continuing with topic 2.4, now we're actually going to be using algebra to write two-column proofs. An algebraic proof is when you're solving your algebraic equation, but you're also listing the properties of equality that are used in each step. So here, when you're doing your algebraic proofs, you're listing your steps to solve problems, and then you're justifying each step as well. So when you have your two-column proof, you're going to have your statements, which is your steps to solve the equation, and your reasons are going to be where you put your algebraic properties or the properties of equality that we talked about in the previous video. So anytime you have an equation, here it's going to be your given. Your given always goes first. So if you look at your algebraic proof, your given always goes on your first statement. And then your reason for that is going to be, well, because that was given to us. And then what you're trying to prove is always going to go on your last statement, because once you get to that last step, you'll have your answer. So here, you're basically solving your equation, but you're writing it out horizontally. Solving is nothing new. It's something you've done before. So here, my first step to solve, I have parentheses, so I would distribute. So 2 times x and 2 times -1, and that changes to 2x minus 2. So I'm just writing out my next step. Because I distributed for my reason in B, I would say that I used the distributive property. So you're just telling how you got from the first step to the next. Now, if I look from B to C, I want to see what's going on. So normally from here, you see they'll combine like terms. So here what happened was they're combining 6x plus 2x and replacing it with 8x. So remember, when you combine like terms or simplify, you're actually using the substitution property. So we're combining like terms here. Again, when you combine like terms, you're using your substitution property. Now we're going to see how we went from C to D. Well, in our equation, we have 8x minus 2 equals 30. I'm going to kind of write up here what they're doing. So we have 8x minus 2 equals 30. Normally from there, you would add 2 to both sides. Here they're doing that. They're just writing it horizontally. So we're adding 2 to both sides. Since we're adding 2 to both sides, we're using the addition property. And then if you look at the next step, all we're doing is simplifying, okay? So here my 2's cancel. On my other side, if I add 30 plus 2, I get 32. So on this step, they're combining 30 plus 2 and getting 32, and then the 2's cancel. So basically, on this step, they're just simplifying or combining like terms. Remember, when you simplify or combine like terms, you're using the substitution property. And then next, once they get 8x equals 32, so I'm going to look here. The next step would be to divide 8 by both sides. Since they're dividing both sides by 8, they're using the division property. And here we know that our 8's would cancel on the left, and on the right, you would get 32 divided by 8 equals 4. Since they're simplifying it, 32 divided by 8 is 4. They're using the substitution property. So you do use the substitution property a lot. It's usually like, okay, once I add or divide, etc., whatever I get, I'm replacing it. So I'm using the substitution property. So here they're replacing 32 divided by 8 with 4. And that's why it's called substitution. If you need to, when you're doing a proof and the statements aren't given, you can solve it on the side and then fill in the steps as you go. So I'm going to do that on problem 2 just to make it a little easier. So again, your given always goes on your first line. So my equation that I'm solving is my given, and I'm going to write that for my first reason because it was given to us. Now they're actually going to start solving it. So again, if you need to work it out on the side, do so. So I'm actually going to work this problem out up here so we can see how they're getting their steps. So since there's x's on both sides, what they're doing is they're undoing the 1x by doing minus 1x to both sides. Here you'll notice they have the minus x on both sides. They're just writing it horizontally. So since we're subtracting x from both sides, we're using the subtraction property. And once you do that, you end up getting 3x plus 8 equals 2. Again, here, since we're just simplifying it or making it smaller, that's why it's called substitution. So on my next step, I have 3x plus 8 equals 2. If I wanted to continue to solve that, my next step would be to subtract 8 from both sides. I'm just going to write this horizontally. So I have 3x plus 8 minus 8. On the other side, I have 2 minus 8. Since I'm subtracting 8 from both sides, that's the subtraction property. If you look up here, we continue to solve, our 8's cancel, and we get 3x equals negative 6. So that would go in my next line. And remember, when you're doing that step where you're just simplifying it, that's called substitution. So anytime you're actually working it out and simplifying, you're using substitution. So my next step, if I have 3x equals negative 6, would be to divide both sides by 3, and you can see they're doing that here. Since they're dividing both sides by 3, they're using the division property. And then on the last step, we're just going to simplify or make this smaller. So my 3's cancel, and I'm left with x equals negative 2, which is what we were trying to prove. So on my last step, I got x equals negative 2. And because I simplified it, like I actually did negative 6 divided by 3 and changed it to negative 2, that's my substitution property. So if you need to actually solve it on the side and then put it in your proof, you can. Just make sure once you get to each step, you're saying what property you're using. If you're adding to both sides, it's the addition property. If you're subtracting both sides, it's subtraction, etc. Once you get to the step, though, where you're actually simplifying, that's called substitution. So again, if you focus up here, like on this step, we subtracted x from both sides. So that was called the subtraction property. On the next step, we just simplified that. So since we just simplified it, and this side 4x minus x became 3x plus 8. On the other side, x minus x canceled, and we just got 2. We were just simplifying it there. So since we just simplified, that's called substitution. So usually after you use a property, you're simplifying, and that's called substitution. If you look at step F, on step F, we divided both sides by 3, so that was the division property. On the next step, we just simplified that. So, okay, now negative 6 divided by 3 is negative 2. Since we were just simplifying, that's the substitution property.